Hello and welcome to lecture 21 of chapter 19 of our comprehensive course on AI, ML and DS. Now, here we want to do a detailed discussion on hypothesis testing. So, this is the first part. What is hypothesis testing? Hypothesis testing is a statistical method used to make decisions about population based on sample data. We have always said that the real art of statistics or machine learning is take a small sample, get various parameters related with small sample, for example, sample mean, sample standard deviation, sample data distribution, and then from that find similar parameters about entire population and get some inferences about the population. That is what is called inferential statistics, right? Now, what can be? So, hypothesis testing is used to make the decision about population based on sample data. And these are some common cases where hypothesis testing is useful. For example, is there significant difference between two groups? For example, in your company, you want to hire a corporate trainer, but his fees are very high. So, what you can do is you can tell the corporate trainer that I will give you the contract for my entire company, but initially you just take two samples of 5 employees each, or 10 employees each, or maybe 30 employees each, to meet the requirements of central limit theorem. So take two samples of 30 employees each. Don't give any training to first sample, and give your corporate training to the second sample, and then I will measure the productivity. So the question under observation here will be, is there a significant difference between the productivity of these two groups? What are two groups? One untrained group and another trained group. And if you find that there is indeed a great enhancement in the productivity for the trained group, then you will give the contract to that costly corporate trainer, right? Similarly, does a certain factor have an impact on the outcome of interest? For example, does the salary of the person depend upon his age, or does the salary depend upon his qualification, or does the salary depend upon his seniority, that is the years for which the person is in your organization? Yes or no for each factor. So you can find the answer to that type of question also using hypothesis testing. And third question is, okay, suppose you find that here in that case of corporate training, you find that giving corporate training enhances the productivity by 10% compared to untrained group. The trained group has 10% higher productivity. But still a question remains that will that 10% increase in the productivity which we found out for two samples of 30 employees each, can it generalize to entire population? Suppose I am running one large multinational company which has maybe 20,000 employees. So will the result which I found for the sample be generalizable? Are they generalizable for entire population? Now, if I want to find answer of this kind of question, then I have to use hypothesis testing. So hypothesis testing helps us determine whether the observed effects or patterns in the sample data are just merely due to random chance, or they represent a true effect in the entire population. So that means the performance gain. Suppose you find that the performance gain did occur compared to untrained sample. The trained sample has a productivity enhancement of 10%. But was it just a mere chance? Maybe that trained sample what we took, they are by default those employees which are highly productive, and the other untrained sample were by default those employees which were not that much productive. Okay, so you don't know. So then, or that means whether the enhancement in the productivity, which is an effect or pattern in the sample data, that was just by random chance, or it was something more than random chance. And if it is something more than random chance, highly probable event, then in that case you will say that yes, I will go with my corporate trainer, right? Now, these are some core concepts in hypothesis testing, and for explaining core concepts, I will use this example. This is our well-known example that suppose your company is selling $50 million on social media marketing, $20 million on TV marketing, $20 million on newspaper marketing, and $20 million on the radio marketing. And as a result, your current sale is $5,000 million. Now, your company plans to try a new marketing strategy. It says that I want to keep the total marketing budget constant. So this is 20, 20, 20, 60 and 50. That is $110 million. Here also, it will be $110 million only, 70 and this to 30 and 10, right? But what I have done is, I have taken $5 million from here and gave it to social media marketing, 5 from here also and gave it to social media marketing, and 10 from radio marketing and gave it to social media marketing, right? And then I want to predict the sales with this new marketing strategy. Now, there can be only two cases. One, that the new sale, sale 2, remains more or less same as the original sale. So that means that there is no significant difference between the sales in the two cases. So you can say that the new marketing strategy is not effective. But on the other hand, sometimes these may occur that the original sale was $5,000 million and the new sale is $6,000 million. So that means you can say that yes, the new marketing strategy is very effective, right? So you want to decide this type of question. So with that example, we will take the explanation of core concepts which are used in all hypothesis testing examples. These are the six core concepts. What is null hypothesis? What is alternative hypothesis? What is significance level? What is p-value? What are test statistics? And what are types of error? So let us discuss these six core concepts with this particular example. Okay. So let us start with null hypothesis. So if you start with null hypothesis, then what is null hypothesis by definition? Null hypothesis is the default assumption that there is no effect or there is no difference by whatever intervention you did to your data, or that means the outcome did not change at all or outcome remained as it is. That phenomena is called status quo. For example, here, what is the intervention that I am doing with my data? I am reshuffling my marketing budget from under 4 different marketing channels, right? But null hypothesis says that you may go on changing these marketing budgets between these. As long as your total marketing budget is same, then there is no difference in the sales. Okay, that is what null hypothesis says, that the new marketing strategy has no impact on the sales. So this is my null hypothesis. Okay, and what is alternative hypothesis? Alternative hypothesis suggests that whatever difference or intervention you did with the data, that created some difference. For example, on the outcome, right? Here outcome is my sales. So for example, alternative hypothesis can say that yes, by reshuffling the marketing budgets, that is by adopting new marketing strategy, my sales has increased. So this blue is my null hypothesis. It says that by adopting this new marketing strategy also, this is strategy 1, strategy 2, but the sale 1 and sale 2 remain same. While this orange one, that is my alternative hypothesis. It says that sale 2 is different and greater than sale 1. So that means the new marketing strategy appears better, right? So null hypothesis usually means no change. For example, if it is cancer detection, then null hypothesis is always meant to be the patient does not have cancer. Okay. Similarly, if it is say customer churn example, then the null hypothesis would be customer does not churn because he is your existing customer. So status quo, everything should remain as they are. So that means customer does not churn. Okay. If it is employee churn example, that your employee is going to leave your organization and go join your competitor. So at that time, the null hypothesis is that employee does not churn, right? So that kind of cases are there. Now, so null hypothesis always means status quo and alternative hypothesis means status quo is not maintained. Now, what is the meaning of then this term? Significance level, third term. Significance level is shown by alpha and it is the threshold for deciding whether to reject the null hypothesis. Okay. So it is normally taken as 5% or 0.05. Now this alpha can be different actually always, but I don't want to add that. Means it can be different in different cases, but I don't want to add complication at present. So far as our discussion is concerned, I will stick to this 5% value or 0.05. Okay. So if it is 0.05, so what does that mean? If the probability of observing the data under H0 is less than alpha, then we reject H0. So what is the meaning? That if I find sales by under first strategy by taking say 50 different samples from my entire organization, whose operations are spread over many countries, and then I find the mean sales for first strategy and mean sale for the second strategy, and I find that the probability P is 0.5. Now 0.5 is 50%. So it is greater than this 5% probability, right? So if there is only less than 5% probability that my data, outcome data, I am talking about outcome data, that is the sale, distribution of sale, would be same as, it would be different than the original sale, then I would say that anything greater than 5% means now my observations of the outcome, they are not falling under my null hypothesis, because null hypothesis says that there is no effect of new marketing strategy, right? But here I am getting suppose p value probability 50%. 0.5 means 50%. Remember this is 0.05, that is 5%, right? So this is 0.5 means 50% probability that my sales do not change. So that means if I take say 50 samples for the old marketing strategy and 50 samples from the new marketing strategy, and if I find the mean for each of these samples, this is the mean of for mu1 to mu2 and so on, right? And similarly, if I find mu1, mu2 for the second marketing strategy also, and then find I true mean, that is the mean of mean that we have already done earlier, so we know in previous lecture. So then we find mean of mean, true mean, and if I have 50% or greater chance, 50% chance that my true mean will also give the same sales, as the sales before sales with the old marketing strategy. So then I will say that new marketing strategy is true mean sales is the same as the old marketing strategy is true mean sales or with more than 50% probability. But this says that if probability is less than 5%, then you can reject. So if the probability of observing the data under null hypothesis is less than 5% alpha, or that means 0.05, then reject null hypothesis. So if it is greater than 0.05, can you reject null hypothesis? No. So you will say that null hypothesis is correct, or that means that there is no effect of changing the marketing strategy on the sales that is confirmed statistically. However, think about this orange color situation. Now here also what we did, again I found 50 samples with old marketing strategy and 50 samples with new marketing strategy, and I found the mean sales for each sample, and I found the actually the mean of those mean sales for first marketing strategy and second marketing strategy, or that is the true mean. Then I got that for first marketing strategy my true mean was $5,000 million, but for second marketing strategy my true mean is $6,000 million, right? So in that case I would say that and that has probability value of 0.02 only, or that means there is only 2% chance that my new data of sale will fall under null hypothesis. Okay, 2% chance, but 2% chance is not enough. At least 5% chance should be there that my sales under new strategy falls under null hypothesis. So this is only 2% chance, 0.02, or I will say that the p value is 0.02, which is less than alpha significance level, and therefore there is no chance because that is very little chance, but that you will take as no chance for my new cell to fall under null hypothesis. Or you can say that we can reject null hypothesis, or we fail to accept null hypothesis. That means alternative hypothesis seems to be correct, right? So that is the meaning of this significance level. Now 5% is just one example. Sometimes we take 10%, sometimes we take only 2.5% like that, but I don't want to add complications, so I stick with this 5% value of significance level. Or that means if I get a probability that my data distribution for the predicted variable is greater than 5%, then in that case I will say that my data distribution still falls under null hypothesis only, and that means that I will say that there is no significant difference between the two. But if the probability of the data distribution of my predicted variable is less than 5%, then in that case I will say that yes, this is not sufficiently convincing to accept my null hypothesis. So I will say that null hypothesis in that case is false, right? So then what is p value? That is coming next, but that I have already explained, that the probability of observing data or something more extreme. Okay, that means data, maybe some sales or some other outcome, whether the person will churn or not churn or anything under the null hypothesis, that is called p value. So always remember p stands for probability, but which probability? So the p stands for probability of observing the data under the null hypothesis. Okay, do not forget that. So it is the probability of observing data under the null hypothesis. And a small p value, which is less than the significance level, indicates strong evidence against null hypothesis. So for example, in this case, I found the probability of observing the data under the null hypothesis is only 2%, but that is less than the significant level of 5%. So my data of the predicted variable, that is sales, will not follow null hypothesis. Will not follow null hypothesis means what null hypothesis says? There is no effect of new marketing strategy on the sales, but this is clear evidence that that null hypothesis is wrong. So then go to alternative hypothesis, which says that there is a difference between the sales under old marketing strategy and the new marketing strategy, right? Now the question is how to find all this. Will you actually take 50 samples and then find the mean sale for 50 samples and then find the mean of mean, that is the true mean? Okay, no, we don't have to do. We have some ready-made tests. What are those? And that test give you this statistic, that is this p statistic, or this kind of this p statistic, or sometimes it indirectly gives the other statistic also, z score or t statistic, etc., f statistic, from which p can be ultimately found. But remember, this p is the key thing, probability of falling under null hypothesis. So even if I am doing t test and first finding t statistic, or z test, first finding z statistic, or f test for first finding f statistic, but ultimately from those z, t or f statistic also I will find the p value only. And then once p value is calculated, we know that if p is greater than alpha, then in that case I would say that the probability of observing the data, that is the predicted data, remember, under my null hypothesis is greater than my significance level. So null hypothesis is valid. But if p is less than alpha, then in that case I would say that null hypothesis is not valid, and therefore we will reject null hypothesis and we will take alternative hypothesis. Okay, so please remember, this is the meaning of these terms. And yes, one more term is the types of error. So there are two types of error. One is called type 1 error and another is called type 2 error. Type 1 error is this, failing to understand this thing. Okay. For example, in this case, I found the mean cell for the 50 sample with old marketing strategy and mean cell, that is the true mean cell for with new marketing strategy, and I got that both are same. Or that means I got the probability also of my sales data falling under the null hypothesis much greater than the significance level. 50% is much greater than 5%, right? So that means that I have to accept the null hypothesis. But suppose by mistake, even though I got this result, I am suppose an amateur statistician, and even when I got this result, which is enclosed in that this green colored box, I reject null hypothesis. But actually, this result says that null hypothesis is to be accepted for this value. Then, if I reject null hypothesis for this green colored box result, then I would say that I have made type 1 error. But similarly, type 2 error also occurs. That is failing to reject null hypothesis when null hypothesis is false. Okay. So, failing to reject null hypothesis when null hypothesis is false. Therefore, this is called false negative. And similarly, that is rejecting null hypothesis when actually null hypothesis is true. Okay. So, therefore, saying that it is false, so that is why it is called false positive, right? While this is called false negative, failing to reject null hypothesis when it is false. So, what is the meaning? Suppose I get this kind of result in this green colored lower or all orange that kind of values. We say clearly that the true mean sale with first marketing strategy is $5,000 million and true mean sale with second marketing strategy is $6,000 million. So in that case, it is clear that the marketing strategies are affecting the sale, and therefore I got the p value also is only 2%, which is less than the significance level of 5%. What does p value give? P value gives the probability that my data means the predicted data will fall under null hypothesis, but there is only 2% probability. But significance level is 5% means there should be at least 5 or more percent probability. So I have to here actually reject null hypothesis, but I fail to reject null hypothesis. Okay. So if I fail to reject null hypothesis, even though null hypothesis is false, that is called type 2 error. So in this case, if I fail to accept null hypothesis, even though it is true, that is called type 1 error. And similarly, in this case, if I fail to reject null hypothesis, even though null hypothesis is false, then that is called type 2 error. Okay. So please remember these 6 terminologies, and now we will take examples in next case. Okay. So practical examples, and these are some examples, right? So see you in the next lecture. Thank you.